Hey, Bio One students. This is Mr. Yance again, and I kind of want to finish up where we left off the other day. So let's talk about acid, bases, and pH, and this will help you with your lab we're going to be doing on Monday. I will videotape that lab on Monday that we're doing in class, and then I'll send it out Monday, and then you guys can do it on Tuesday. So acids, bases, and pH. That's pretty much where we're at right now, and it relates to water. So what's in this section of 2.2, and it's very important that cells buffer against rapid changes in what we call pH. So we're going to go over pH today, and that's what the lab's going to be on Monday. So buffers are pretty much things that are dissolved in our fluids, our cytoplasm of our cells, and our body fluids, and it helps maintain homeostasis, one of those characteristics of life that we talked about last chapter. So what are these acids and bases and pH and all this good stuff? So when you talk about water splits apart into two things. So you got H2O, right? So H2O is basically hydrogen and hydroxides. So the hydrogen is obviously the H plus on this screen. The OH negative is the hydroxides. And you can see the arrows go both directions, which means it's a reversible reaction. And that's what you find when water splits. And we also can put water back together. So one's called hydrolysis. That's what it shows on the top. And then we put it back together. Then that would be dehydration synthesis. We'll talk more about that in photosynthesis and respiration. So what happens when hydrogen splits off of the OH? That's basically what we're going to talk about today. And it doesn't happen a lot, but it happens in about 1 out of 550 million splits. And what we're going to form is ions. And if you guys remember from earlier in notes, ions have a positive and negative charge. So being that water is neutral, we have the same amount of protons as we do electrons, the 10 number there. That is what it is. But when we split it, now we're going to create these ions, these positive and negative charges. And that's where the pH scale comes in. So pH is a scale from 0 to 14. And right in the center of that pH scale is at number 7 is pure water. Now understand something. Most water that we drink and we use is not pure water. Water dissolves things very quickly. We talked about that the other day. And pure water in its purest form, usually we have to do that in a lab. We have to purify it and distill it, we call it. So most water is not that way. And you'll see that when we do some testing in the lab Monday. One station is water, and it won't be pure. It'll be close to 7, but it won't be exactly 7. So that's basically what we're going to talk about here in the next few minutes is what is this 0 to 14? What is something that's above 7? What is something below 7? So we're going to use 7 as that kind of center point that we're going to go off of, okay? I want to show you a little quick video real quick, and then we'll kind of talk about pH here in just a second, okay? So here we go.
I got nothing.
Mark, look.
Well, yours is turning color.
Because you're just not using enough carbon dioxide. Look at that. Keep going. You're pretty close. You're like 10 more seconds. Right? No more than like 30 seconds. No, you're good. Look at that right now. See? Look. What are you? Look at you. All right. So this is
good?
Well, this just is an indication of carbon dioxide.
Oh.
It would have been a whole lot easier if we would have done this because what we had inside was an indicator. It's called phenolphthalein, a little bit of a base. Put on your gloves.
Okay.
And believe it or not, the carbon dioxide in your breath has nothing to do with your breath. You know, it's just carbon dioxide. Get a piece of dry ice. If you would have just put a piece of dry ice in there, it would have happened a lot faster. Here, watch this. Notice how it goes down. We're generating carbon dioxide gas. That carbon dioxide gas is an acid acid.
Oh my gosh.
Isn't that amazing? So it's a nice little change. So see, it would have been so much faster with just a little chunk of carbon dioxide. Hey, let's show people at home how they can make their own indicator. Years ago, you could take X-Lax tablets and grind them up, and you would make that pink stuff if you put it in a little bit of alcohol with a base. So let's move this off to the side, and I'll show you how we're going to do it. So it's time for our little cooking segment. All right. So what you're going to need is some red cabbage juice, because there is a chemical inside that red cabbage leaf that is just a wonderful dye. Got it? So this goes down inside here like this. Okay, and now this goes on top, and now you just kind of grind it. Again, compelling television.
This is like a Saturday Night Live scene.
Will it's blend.
Will it blend?
There you go. All right, so there you go. So believe it or not, that's it. Now the whole studio is going to smell so pretty for the next 3 hours of news. All right, so here's what's going to happen. Now we strain it out, and this is our indicator. So believe it or not, that purple juice right there is a beautiful acid-base indicator. So that's all we need. So if you'll bring over the little graduated cylinder, let's use the brand new one here. Yeah. So now take a look at this. Let me fill it up. So here's our indicator. So this is showing kind of a pH of 7. So that's just in the very middle. It's water. If we were to add a base to it, look at this. A little ammonia goes inside. So here's a little bit of a base. Notice the color change that we get here. Look at this. We do. So watch this as you stir it.
Oh, look at that.
Isn't that absolutely gorgeous?
Who knew that there was so much chemistry in bad breath?
See, it was just the hook to get you in. So this is green if it's a base, and if we trip it back with vinegar and it's an acid, watch it kind of come back this way. It's just a real kind of pretty reaction that's there. Isn't that kind of fun? So as you stir it, so just using cabbage juice, believe it or not, a nice little way to do it. And if they're checking the pool, for example, they use the
Okay, so you can see right there, we're going to use some indicators. We may do that. If I get inspired, I may make some of that red cabbage juice this weekend, and that might be one of the stations I show you on Monday. So what is acids and bases? That's pretty much where we're at. What is the difference between them? So that's what they were showing you on that screen. So let's start out with what these numbers mean. So you got 0 through 14. So at every number, that is a factor of 10. So pH of 4 has 10 times as many hydrogen ions as a liter of pH of 5. Now understand, though, that's a factor of 10. So if I go to 6, then that's 10 times 10. I go to 7, 10 times 10 times 10. You can see how it's going to get a lot stronger. I should say the other way. If I go 3, then 2, then 1. So it gets stronger as we go down. You can see it on the scale here of increasing acidity and increasing basic. Okay, so let's start with acids. Acids are anything from below 7. So when you're doing testing, and we'll do this Monday, anything that's below 7 is going to be an acid. That means I have more hydrogens than OHs, more hydrogens than hydroxides. Now, low numbers are strong acids like HCl, which is what we find in stomach acid. I mean, you literally could take stomach acid, put it on the table, or burn through the table. That's how strong it is. So on the test, which is going to be next Thursday, be careful on a couple of questions, because I'll have this scale right here, and I'll say, okay, what on this scale is a strong acid? You put stomach acid. What is a weak acid? You would put milk or normal rainfall, because the closer to 7 we get, the weaker the acid is. The further away from 7 to get, the stronger the acid, and the bases work the same way. Okay, so be careful on those questions. Don't miss those questions. So acids are anything that's low. So you got to be really careful with those acids, because a lot of these acids that are 1, 2, 3, they'll burn your skin if you get them on you. Okay, so you have to be super careful with anything that's low. Same thing with bases. Bases are the other direction. Anything above 7 is a base. That means I have more OHs than acids. Okay, so when you're talking about a strong base like lye, that would have a pH, anywhere between 11 to 14. So same deal. If I have something that has a 13 for a pH, that's a strong base. If I have something at 7.5, that's a weak base. Hopefully that makes sense to you, because we're going to work with this next week. The lab's about all this, and we'll talk more about it next week as well. Last 2 slides, and then we're done. Okay, and then we'll do a lab. I'll have a review game next week, and you guys will be caught up. In fact, you'll be actually a little bit ahead, because I haven't went over buffers with my classes yet. So Buffers are things in our body. Generally, we like to keep things between 6.5 and 7.5 in our body, in that mid range. We don't like extremes on the acid side. We don't like extremes on the base side. So our body controls pHs all the time with something called buffers. So, here's the common misconception. They're like, okay, if I have a strong acid, I'm just going to pour a really strong base in with it, and I'll bring it up really fast. But that's what the body does not want to do. We don't want to bring stuff up really fast. So what we do is we just bring it up with a weak acid, a weak base, and we bring it up nice and slow. So I have a low pH in my blood. The body's going to release a weak base to kind of bring it up nice and slowly. If I have a strong base in my body, then I'm going to take a weak acid and bring it up really slow. The key here is not to bring it up so sharply that changes in pH will cause us all kinds of problems. Think about this. I'll give you a really good example, and then this last slide, and we'll be done. Think about when you get an upset stomach. So a person has an upset stomach, you're producing way more acid than you need to. So what we do is we take a Tums. A Tums is a buffer that actually brings up, it's a base, but it's a weak base, and it brings things up really, really slow to keep that sharp change from happening. So as you can see on this last slide, adding an acid to an unbuffered solution causes the pH of the unbuffered solution to drop. If that solution contains a buffer, adding that acid will only cause a slight change. So the buffers is a way of counteracting an acid or a base in the body or in any living thing. That doesn't have to just be us, okay? So look through the notes. We got lab. Hopefully some of this stuff will make a little more sense after the lab. We'll have a Kahoot game on Wednesday, and then Thursday during your class time, whatever your class time is, we'll take a Google form test like we did last time. And some of you did not take that first test. So we got to make sure that we log on, get these tests taken, look at the Kahoot. I'll put these notes online. I'll do that this weekend. So you can look at the notes, you can watch my videos, you can do whatever you need to do to get ready for that test Wednesday. And that is Thursday. That is the last test of the grading period. So the grading period, believe it or not, is over this next week. So please, please, please look at anything you're missing, get some stuff in so I can get your grade where it needs to be. Okay. Have a great weekend, and we'll talk to you next week. See ya. Bye.